The internet is a vast interconnected network of networks. It connects billions of devices worldwide, allowing them to communicate and share information. This intricate web spans continents and oceans, linking computers, smartphones, servers, and countless other devices. The internet's structure is decentralized, meaning there is no single point of control or failure. Instead, it relies on a complex system of interconnected networks that cooperate to transmit data. These networks, operated by internet service providers, ISPs, range from small local providers to global telecommunication giants. They connect using high-speed fiber optic cables, satellite links, and other communication technologies. Each network acts as a node in this global web, forwarding data packets along the most efficient route to their destination. The beauty of the internet lies in its ability to connect diverse devices and networks seamlessly. Whether you are sending an email, browsing a website, or streaming a video, the underlying principles remain the same. Data is broken down into small packets, each containing information about its origin, destination, and content. These packets travel independently across the internet, hopping from one network to another until they reach their intended recipient. The internet's decentralized nature makes it remarkably resilient. If one network or connection fails, data can be rerouted through alternative pathways. This redundancy ensures that information can flow freely, even in the face of disruptions. The internet's open architecture also fosters innovation, allowing developers to create new applications and services that leverage its global reach and connectivity. The internet relies on a combination of hardware and software to function seamlessly. Hardware refers to the physical components such as computers, servers, routers, and cables that make up the network infrastructure. Software, on the other hand, encompasses the protocols and programs that govern how data is transmitted and processed. These protocols act as a set of rules, ensuring that devices from different manufacturers and networks can communicate effectively. Routers are essential hardware components that direct data packets between networks. They act like traffic controllers, analyzing the destination address of each packet and determining the optimal path for it to travel. Switches, another crucial hardware element, connect devices within a local network. They create a direct link between devices, allowing them to exchange data quickly and efficiently. Servers, powerful computers that store and process information, play a vital role in hosting websites, email services, and other online applications. Protocols are the language of the internet, providing a common framework for communication. One of the most fundamental protocols is the Internet Protocol (IP), which defines how devices are addressed and how data packets are structured. Each device connected to the internet has a unique IP address, allowing it to be identified and located within the network. The Transmission Control Protocol (TCP) complements IP by ensuring reliable data transmission. TCP establishes a connection between devices, divides data into packets, and verifies that all packets arrive at their destination intact. These protocols work in tandem to ensure that data flows smoothly across the internet. They handle tasks such as error checking, data segmentation, and flow control, ensuring that information is transmitted accurately and efficiently. The internet's reliance on standardized protocols is key to its interoperability, allowing devices from different vendors and networks to communicate seamlessly. When you send an email, browse a website, or stream a video, the data you interact with embarks on a fascinating journey across the internet. This journey begins with your device, be it a computer, smartphone, or tablet, which connects to the internet through an internet service provider, ISP. Your ISP acts as your gateway to the wider internet, providing you with an IP address and a connection to its network. When you request information, such as by typing a website address into your browser, your device sends a data packet containing your request and your IP address. This packet travels through your ISP's network, hopping from router to router until it reaches its destination server. The server processes your request, retrieves the requested information, and sends it back to your device in the form of data packets. The process of translating human-readable website addresses like google.com, into numerical IP addresses is handled by the Domain Name System, DNS. DNS servers act like internet phone books, mapping domain names to their corresponding IP addresses. When you type a website address, your device contacts a DNS server to retrieve the IP address of the server hosting that website. This process happens behind the scenes, ensuring a seamless browsing experience. Data packets travel across the internet using a variety of communication technologies, including fiber optic cables, satellite links, and wireless networks. Fiber optic cables offer high bandwidth and low latency, making them ideal for transmitting large amounts of data quickly. Satellite links provide connectivity to remote areas where terrestrial infrastructure is limited. Wireless networks, such as Wi-Fi and cellular data, offer flexibility and mobility, allowing devices to connect to the internet without physical cables. The internet's ability to deliver data to its intended destination relies on a complex system of routing. Routers, specialized networking devices, play a crucial role in this process. They act like traffic directors, analyzing the destination address of each data packet and determining the optimal path for it to travel. Routers maintain routing tables which contain information about the networks they are connected to and the best routes to reach various destinations. When a data packet arrives at a router, the router examines the packet's destination IP address and consults its routing table. Based on this information, the router determines the next hop in the packet's journey, forwarding it to the appropriate network or router. This process repeats at each router along the path, ensuring that the packet eventually reaches its intended destination. Switches, another important networking device, connect devices within a local network. Unlike routers, which operate at the network level, switches operate at the data link layer, connecting devices directly within a network segment. Switches learn the MAC addresses of connected devices, creating a direct path for data transmission between them. This direct connection eliminates the need for packets to travel through multiple routers, improving network performance. Internet service providers, or ISPs, are the companies that provide internet access to individuals and organizations. They operate large networks of routers and other infrastructure, connecting users to the wider internet. ISPs offer various connection types, including DSL, cable internet, fiber optic, and satellite, each with its own characteristics in terms of speed, reliability, and cost. ISPs play a critical role in ensuring that data flows smoothly across the internet, managing network traffic, and maintaining connections between different networks. The internet's ability to transmit data reliably and efficiently relies on a layered communication model known as the TCP/IP model. This model divides the communication process into 5 distinct layers, each with its specific functions and responsibilities. These layers work together seamlessly, abstracting the complexities of data transmission and ensuring that information flows smoothly between devices. At the bottom of the TCP/IP model is the physical layer, which deals with the physical transmission of data over the network medium. This layer defines the electrical and mechanical characteristics of the connection, including the type of cables, connectors, and signaling methods used. The data link layer, situated above the physical layer, handles error detection and correction, ensuring that data is transmitted reliably across the physical link. It also manages media access control, determining which device can transmit data at a given time. The network layer is responsible for routing data packets across the internet. It uses the Internet Protocol, or IP, to address devices and determine the optimal path for packets to travel. The transport layer, located above the network layer, provides reliable end-to-end communication between applications running on different devices. It uses the Transmission Control Protocol, or TCP, to establish connections, divide data into packets, and ensure that all packets arrive at their destination in the correct order. The application layer sits at the top of the TCP/IP model, providing services to user applications. This layer includes protocols such as HTTP for web browsing, SMTP for email, and FTP for file transfer. The application layer interacts directly with user programs, enabling them to communicate with other applications across the internet. As the internet has become an integral part of our lives, ensuring the security of our data and communications has become paramount. Internet security encompasses a wide range of measures designed to protect against unauthorized access, data breaches, and other cyber threats. These measures aim to safeguard our personal information, financial transactions, and online activities from malicious actors. One of the most fundamental internet security measures is encryption. Encryption involves transforming data into an unreadable format, making it incomprehensible to unauthorized individuals. Secure Sockets Layer, or SSL, and its successor, Transport Layer Security, or TLS, are widely used encryption protocols that secure communications between web browsers and servers. Websites using these protocols display a padlock icon in the address bar, indicating that the connection is encrypted and data transmitted between the browser and server is protected. Virtual private networks, or VPNs, provide another layer of security by creating a secure tunnel for your internet traffic. When you use a VPN, your internet traffic is routed through an encrypted tunnel to a VPN server located elsewhere. This encrypts your data and masks your IP address, making it more difficult for third parties to track your online activities or intercept your data. VPNs are particularly useful when connecting to public Wi-Fi networks, which are often unsecured and susceptible to eavesdropping. Firewalls act as a barrier between your device or network and the internet, blocking unauthorized access and filtering incoming and outgoing traffic. Firewalls can be implemented in hardware or software, and they operate based on a set of rules that define which types of traffic are allowed and which are blocked. Firewalls can prevent malicious software from entering your network, block access to suspicious websites, and protect your devices from unauthorized remote access. The Internet's history is a testament to human ingenuity and collaboration. Its roots can be traced back to the 1960s with the development of ARPANET, a project funded by the U.S. Department of Defense. ARPANET was designed to connect research institutions and military installations, allowing them to share information and resources efficiently. It was a groundbreaking network that laid the foundation for the Internet we know today. Over the decades, the Internet has evolved dramatically, expanding from a niche network to a global phenomenon. The introduction of the World Wide Web in the 1990s revolutionized the Internet, making it accessible to a wider audience and ushering in an era of unprecedented information sharing and online communication. The development of new technologies such as broadband internet, mobile devices, and cloud computing has further fueled the Internet's growth and transformed the way we live, work, and interact. The future of the Internet holds immense possibilities. The advent of 5G networks promises to deliver significantly faster speeds, lower latency, and increased capacity, enabling new applications and experiences. The Internet of Things, or IoT, is another transformative trend, connecting everyday objects to the Internet and creating a network of intelligent devices that can collect and exchange data. From smart homes and wearable technology to autonomous vehicles and smart cities, the IoT has the potential to revolutionize various aspects of our lives. As the Internet continues to evolve, it is essential to address challenges such as cybersecurity, data privacy, and digital divide. Ensuring a safe, secure, and inclusive Internet for all is crucial for realizing its full potential and harnessing its power for good. The Internet has come a long way since its humble beginnings, and its future promises to be even more transformative, connecting people, ideas, and possibilities in ways we are only beginning to imagine.